This is section 11.2 on rational exponents. It says another way to write radical expressions, all the square root stuff we've been talking about, is with what we call rational or fraction exponents. And sometimes this will help us simplify expressions. So we're going to go over the basics of rational exponents, and then you'll see how they get used to help simplify expressions. You might want to have your calculator handy as well as your power chart. Both of these can be helpful for this section. So we're used to seeing the square root of 9, but it can also be written 9 to the 1/2 power. And in your calculator, if you do 9 raised and then parentheses 1/2, so 1/2 is all in the exponent, you should get the same answer as if you were to do the square root of 9. So it's just another way of writing the same thing. Same idea with the cubed root of 8. We can also write that as 8 to the 1/3 power. So if I do 8 raised to the 1/3 power, it gives me the same answer as the cubed root of 8, which is 2. And then one last time, the 4th root of 81 can be written 81 to the 1/4 power. So if I do 81 to the 1/4 power, I also get 3. So in your calculator, it's helpful to know that you can write radicals with fractional exponents. And so that's how you would type it into the calculator. Especially if the root is really big, like 1/12 or 1/15. If this number is really big, then it's easier to type it in as a rational exponent. So the rule is that whatever the root is for x, whatever the number is, it's x to the 1 over that root. So this is what I call the root. I think the textbook calls it the index. So that's the root. And then this is the power on the term. So if it's just plain old x, that's x to the 1 power, which is why it's a 1. So this 9 is to the 1 power, which is why that's a 1. This 8 is to the 1st power, which is why that's a 1. 81 is to the 1st power, which is why that's a 1. So it's power on top, root on the bottom. Same thing here, that's the root, and that's your power. Power goes on top, root goes on the bottom. And the way I think about that is like a tree. Please forgive my drawing. So for a tree, we have your roots on the bottom and the power at the top. So that's how I remember that. Root on the bottom, power on the top. So we're just going to practice switching back and forth between radical form, which is when you use the square root symbol, and this is called rational exponent form. Just practice switching back and forth a little bit, and then we'll see how we put it to use. So let's rewrite each expression using rational exponents. So x is your base, 5 is your power, 3 is your root. And you want to make, it's kind of hard to see on the typed version, but the exponent should be higher than the problem. You want to make sure it looks like it's an exponent. The entire fraction 5/3 is an exponent. Same thing here, the root would be 2 because it's a square root. The power is 3, so we have x to the power over the root. Same thing here, the root is 2, the power would be 1, so it would be x to the 1 over 2. Here the root is 4, the power is 5, so 5 over 4. And then last but not least, we have a root of 3 and a power of 1, so it's x to the 1/3. So some of your homework just wants you to practice switching between radical form and rational exponent form. We're not really solving anything or getting any sort of answer, we're just practicing. Let's put it to use with some values here. Rewrite each expression using radicals and then simplify. So 25 to the 1/2 power is the same thing as the square root of 25. which is 5. 27 to the 1/3 power is the same thing as the cubed root of 27, which you can use your power chart to help you out there. The cubed root of 27 would be 3. 1 over 49 to the 1/2 power would be the square root of 1 over 49, which would be 1 over 7. Negative 8 to the 1/3 power would be the cubed root of negative 8, and that would be negative 2. And then we have 16x to the 6th to the 1/2 power. That would be the square root of 16x to the 6th. Let's see, the square root of 16 is 4. Square root of x to the 6th is x to the 3rd. So just rewriting it into radical form and then using everything we've learned about radicals so far to simplify. If you'd like to try the next set on your own, you're more than welcome to, or you can follow along with me. These might be a little more challenging, so you might want to follow me first. So we have 81 to the 3/4 power. So that's the 4th root of 81 to the 3rd power. And they want you to simplify that. And 81 to the 3rd power is going to give you a huge number. So what I recommend is to do the root first and then the power. You can do it in any order, but it's just easier to manage if we get the numbers smaller before we make them bigger. So if we think of this as the 4th root of 81 and take that answer and raise it to the 3rd power, it just makes it a little bit easier. So the 4th root of 81 is 3. And then we'll take 3 and raise it to the 3rd power, which is 27. So it's a little bit easier to do the root first and then the power. Same idea here. We have the cubed root of negative 8. It's good to figure that out first and then square it. The cubed root of negative 8 would be negative 2. Negative 2 squared is 4. So root first and then the power. The cubed root of 216, and then we'll take that answer and raise it to the 4th power. So let's see, 3rd root of 216 would be 6. And then we'll take 6 and raise it to the 4th power, which would be 1296. So root first and then the power. If you'd like to try the last two on your own, you can. We've got the 5th root of 32x to the 5th. We'll figure that out and then square it. The 5th root of 32 would be 2. The 5th root of x to the 5th is x. Then we're going to square that. So 2x times 2x would be 4x squared as the final answer. And last but not least, we have the square root of negative 16. Then we'll raise it to the 3rd power. We cannot square root a negative, so we have a non-real answer, which means we cannot cube it because we also cannot square root it. So we have a non-real answer for the last one. So the most important part there is to do the root first and then the power. Let's keep going here. So the next part is just a quick review of our exponent properties. You should be familiar with these already. If not, remember they're in section 5.1 of your textbook, or you can Google them, is fine too. You want to be familiar with your exponent properties. The first one that we should all know is the product property. If you multiply two terms with the same base, you can, that should say a plus b. Add the powers. So if I have x to the 5th times x to the 7th, I would do 5 plus 7 to get 12. Here, if I have x to the a over x to the b, it is x to the a minus b. So if I have x to the 7th over x to the 5th, I would subtract them. I would do 7 minus 5. It's always the top minus the bottom. And last but not least, if I have x to the a raised to another power, then I multiply the powers. So if I have x to the 5th raised to the 7th power, I multiply 7 times 5 to get my power. So you should be familiar with the simple product rule, quotient rule, and power rule for exponents. We're going to use that same idea for rational exponents. The reason these look worse is because they're fractions, but the math is the same. So if I have x to the 4/3 times x to the 5/3, I would do x to the 4/3 plus 5/3. As long as the denominators are the same, I can add them together to get 9/3. And 9 divided by 3 is just 3. So my final answer would be x cubed. Same idea here. If I have y to the 5/3 times y to the negative 2/3, it would be y to the 5/3 plus negative 2/3. Because the denominators match, I would do 5 plus negative 2, which is 3. And 3 divided by 3, I did not write that very well. This would be 3/3 for a final answer of y to the 1st power, or just y is fine as well. So we add the powers if we're multiplying the same base. The bases have to match for that. Same idea with the quotient rule. We can subtract the powers. So 10 to the 2/3 over 10 to the 1/9 would be 10 to the 2/3 minus 1/9. We have to have common denominators to subtract them, so I'm going to have to get that common denominator, which should be pretty easy. I like to use a different color for this part. Multiply that by 3/3. That's going to give me 6/9 minus 1/9, which is 5/9. So my final answer would be 10 to the 5/9. So sometimes you have to get common denominators with those fractions. Same idea on the second one. This would be x to the 3/5 minus 1/10. To get common denominators, so I'm going to multiply this one by 2. That's going to give me 6/10 minus 1/10, which is 5/10, which I can reduce to 1/2. So my final answer would be x to the 1/2. So just using our basic fraction operations and our exponent properties. Here's a couple of power properties. If I have 81 to the 1/4 times x to the 3/4, and I'm going to have it all raised to the 2nd power, the 2 is really over 1, and I would multiply top times top and bottom times bottom. So that's going to give me 81 to the 2/4 times x to the 6/4. 81 to the 2/4 is really 81 to the 1/2, and this can reduce to 3/2. 81 to the 1/2 is the square root of 81, which is 9, and then x to the 3/2. Let me just leave it just like that. On this one, we'll distribute the 1/6. The 64 is to the 1st power, the x is to the 12th power. You can put those both over 1, so you can multiply easier. That's going to give us 64 to the 1/6 power times x to the 12/6. 64 to the 1/6 is the 6th root of 64, so here's 6th root of 64 is 2. So I'm going to rewrite this with just 2. 12/6 is just 2, so it's x squared. So that simplifies down to 2x squared. So you're really combining a lot of different properties here. Your exponent rules, your fraction rules, your power rules, everything that we've learned kind of gets combined for these problems. A couple more. So here they are in radical form. And in radical form, it looks like there's nothing we can do with them. However, we can convert them into rational exponents, and then work with them. So before we said the roots have to match in order to multiply them together, but if we convert them into rational exponents, then I can do something with it. So I can do 1/3 plus 1/2, and I can get common denominators. So that would be x to the 2 over 6 plus 3 over 6 for a final answer of x to the 5 over 6. And because the original problem was in radical form, I'm going to convert that back to radical form, the 6th root of x to the 5th. So whatever form it starts in is the form you want to have your final answer in. Same idea here. As it stands right now, it looks like there's nothing I can do, but if I convert it to rational exponents and make this x to the 1 over 12 times x to the 2/3, then I can use fraction rules to add them together. So 1/12 plus 2/3. I'm going to multiply this guy by 4. That's going to give me 1/12 plus 8/12, which is 9/12, which reduces to 3/4. So that gives me x to the 3/4. And because it was in radical form to begin with, I'm going to convert it back into radical form, the 4th root of x to the 3rd. So when you use your little fraction rules, get it down to a simplified fraction, and then convert it back into radical form. Same idea with the quotient rule. Right now it looks like there's nothing we can do, but if I make this y to the 1 over 8 divided by y to the 1 over 9, I can make common denominators. 9 over 9, 8 over 8. So that will be y to the 9 over 72 minus 8 over 72, which is 1 over 72. So that would be y to the 1 over 72. And we can rewrite that in radical form, the 72nd root of y to the 1st. And you don't have to put to the 1st, it just kind of helps your brain see where the numbers are coming from. And same idea here. I'm going to convert this into radical form. I'm sorry, rational exponent form. So I have x to the 4th, y to the 3rd, being raised to the 1/12th power. I want to distribute that 1/12th power, so I'm going to put these guys both over 1 and multiply them down. That's going to give me x to the 4 over 12 times y to the 3 over 12. And I can reduce that to x to the 1/3, y to the 1/4. And I can write those as two separate radicals, the cubed root of x times the 4th root of y. And sometimes that comes in handy, it just depends on the problem. Separating them back out can help you find the next step in your process. Right now we're just practicing using the conversion to help us simplify. Main thing here is if it starts in radical form, it usually wants the answer in radical form. And last but not least, rewriting using radicals. Students really overcomplicate this problem. There's really nothing to do. You have 2x minus 5, but there's nothing to do with 2x minus 5. So you just have to remember that 3 is the power and 5 is the root. And all it wants you to do is write it as the 5th root of 2x minus 5 to the 3rd power. And again, that will come in handy for solving. Right now there's really not much to do with it. It's just rewriting it from rational exponent form into radical form. So that's all it wants you to do. And that is converting radicals with rational exponents.